Hi guys, in this video what we're going to do is just going to have a quick revision of basically the trig ratios sine, cos and tan. So we've already done this in second year, and this only works, if you remember, for right angle triangles. So you can see we have a right angle triangle here on the right hand side, and it's been labelled with respects to the angle. So if the angle A is here, the longest side is always the hypotenuse. The side opposite the angle that we're dealing with is called the opposite, which means that the other one is called the adjacent. Okay, so that's how we get the three sides. We should know around the SOHCAHTOA, so SOHCAHTOA, and sine A is equal to the opposite over the hypotenuse, cos A is equal to the adjacent over the hypotenuse, and tan A is equal to the opposite over the adjacent. Okay, this is all very well known. Now, what you might not have known is the fact that we can actually write tan of A is equal to sine A over cos A, and this is an example of what we call a trig identity, and we'll be dealing with these further in the course. So the other thing that we've got to deal with when we're looking at right angle triangles is obviously the law of Pythagoras, and Pythagoras stated that the sum of the squares of the smaller side is equal to the square of the larger side. So essentially what he said was that a squared plus b squared is equal to the hypotenuse squared, which is c squared here. Again, something that we've done on numerous occasions up until now. Just for clarification, if you see the angle of elevation, so the angle of elevation here, that means that we are looking up from the horizontal, so the angle of elevation is here. So the angle is from the horizontal to the angle that's going up here. And likewise for the angle of depression, okay, that's when again it's come the horizontal. Notice it's the horizontal both times, and instead of going up in this case, which was the elevation, we are looking down, which is the angle of depression. Okay, let's have a look at an example. So Seamus wants to measure the height of a small tree which is located on the horizontal ground. He stands a distance of 10.35 meters away from the tree and measures that the angle of elevation to the top of the tree is 27.5 degrees. As you can see on the diagram here, he's obviously standing here and he's looking up. Okay, that's why it's elevation. It says here his eye level is 1.8 meters above the ground, so we're not taking the triangle from the ground, we are taking it from slightly above the ground, 1.8, and that's where we're going to do all our working from. It says calculate to 2 decimal places the height of the tree. So hopefully you can see here we have a right angle triangle, we have an angle and we have a length. So therefore we should be able to calculate this distance from here to here, which I'm just going to call D. Don't forget at the end though, if we want to find the total height of the tree, that we still have to add on this 1.8 here. Okay, so don't forget to do that at the end. So let's label the triangles. We know that the longest side is the hypotenuse, we're happy with that. Let's then have a look at what we need. So we've got an angle, great. This here is opposite the angle, so this is the O, and this is the adjacent. Okay, so what we have here is we're only interested in O and A because we've got a variable here, we've got a constant here, we have an angle here, O and A. And if you look in your tables books, you'll find that tan of the angle is equal to the opposite over adjacent. Okay, so that's the one we're going to use. Now all we have to do is stick in the values. So we've got the angle, so tan of 27.5 is equal to the opposite, which is D, over the adjacent here, which is 10.35. Now what some of you like to do is you like to get your calculator out and now work this out. And if you do that, you're going to get a decimal. It's going to be a pain in the hoop if I have to start manipulating or rearranging this formula. We don't have to in this particular case. So what I suggest you do is you don't put that in your calculator until you have the variable, which in this case is D, until you have it so that it's on its own. So I want to get rid of this divide by 10.35, not a bother. So D is equal to, multiply everything by 10.35, I get 10.35 multiplied by tan of 27.5. I now have this variable isolated, which means that all I have to do is stick this in the calculator and I won't lose any accuracy due to rounding by using so many decimal places. Sticking that in the calculator, you get D is equal to 5.38788689 blah blah blah, and we've been asked to do it to 2 decimal places, so that portion D is equal to 5.38 9 meters. However, you've got to remember as well is if we go back to the diagram, all we've worked out is this bit here. So in order to finish this off, we have to add 1.8. So we're going to say the height is equal to 5.39 plus 1.8, and that's equal to 7.19 meters. Okay, so there's the first part done. So for the second part, Seamus wants to lie on the floor. Why not? And he wants to now try and work out the angle here. So we already know that it's 7.19, don't we? So we know that that total distance from here to here is 7.19 meters. But he says that his eye level is now 0.3 meters above the ground. So we're not going to be using that. So in order to find the triangle that we're going to use here, what we have now is, if we just quickly draw it, we know he's still the same distance, which is 10.35. We're trying to find this angle. I'm going to call it theta, okay? And then what we have then is it's not 7.19 meters now because we have to take away the 0.3 that he's up off the floor. So it's going to be 6.89 meters and the height there that we're trying to work out for the angle. Okay, again, what we're going to do is just quickly label this. It's fairly trivial now. HOA, it's exactly the same. And hopefully you can see that it's still going to be tan. So let's write down our ratio and then work from there. So what I have now is that tan of A, or theta, sorry, is equal to the opposite. And the opposite here is 6.89 divided by 10.35. Okay, so that's what we have here. Nice and straightforward. We don't have to stick that into our calculator just yet. Again, as I said, what I'd like to do is I'd like to get the angle or the unknown on its own. So in order to get rid of a tan, we have to do the inverse function. And the inverse function of tan is tan to the minus 1 on your calculator. So I'm going to tan to the minus 1 both sides. Here's the first one. Tan to the minus 1 this side is equal to tan to the minus 1 on the other side. Because remember, whatever I do to one side of the equation, I have to do to the other. So we end up with tan theta here is equal to tan to the minus 1, 6.89 over 10.35. Now, when you see a number or a function with this inverse function, what happens is they essentially cancel each other out. So what's going to happen here is this tan to the minus 1 and the tan here are going to disappear and leave just theta, and then we just stick this into our calculator, making sure, lads, that we are in degree mode. So this is now going to cancel out, so I end up with theta is equal to, stick this into your calculator. Again, if we leave it to the end, we don't lose any exactness, and if you do that, you're going to end up with 33.65, and that's degrees. Okay, this is a nice example here where we're told that we've been given a trigonometric ratio, which is sine A is equal to 3 over 8, and we are then asked to calculate cos, tan, or whatever they ask us to here. So it says if sine A is equal to 3 over 8, where it's between 0 and 90, the angle, express cos A in the form of root k over m, where k and m are members of the natural number family. Okay, first thing to remember here is as soon as I see sine A, that means it has to be a right angle triangle, or I can write it as a right angle triangle. So what I'm going to do, I'm just going to draw a right angle triangle. I'm going to put in my angle, it's called A, so I'll leave it as A. And we know that if we have a look at the ratio, sine A is equal to the opposite over the hypotenuse. So let's just quickly label this. We know that this is the hypotenuse, we know that this is the opposite, and we know that this is the adjacent. Okay, if you're not sure, just put adj there just to make sure you don't get confused with the A, the angle A. And we know that sine A is equal to opposite over the hypotenuse. So, okay, so if we know that sine A is equal to 3 over 8, we know that, according to this then, that the opposite must be 3 and the hypotenuse must be 8. Okay, so let's put that into our triangle, and I'll put it in red. So we know the opposite is 3 and the hypotenuse is 8. Now, we have a right angle triangle. Should really draw a right angle in there. We have a right angle triangle and we have two sides of that triangle that we are given. That now means that we can find this by our old friend Mr. Pythagoras. So remember, it's going to be this squared plus this squared is equal to the hypotenuse squared. So I'm just going to call this x, okay, and we'll put the number in when we find it. So we know that x squared plus 3 squared is equal to 8 squared. So work out those numbers. X squared plus 9 is equal to 64. X squared is equal to 64 take away 9, which is 55, and then take the square root. X is equal to the square root of 55. So we now know that the adjacent is equal to the square root of 55. So we can put that on our diagram up here now. So that's the square root of 55. It then says we want to find cos A, so find cos of the angle. Okay, that's not a problem. We know that cos A is equal to, well, this time it's the adjacent over the hypotenuse. We've just worked out the adjacent. So we have adjacent is equal to root 55, because that's the one we've just done here. Adjacent over the hypotenuse, which is 8, which now means that we know that in this particular question, k is equal to 55, and it also means that m is equal to the denominator, which is 8. The last thing we're going to look at on this video is the special trig ratios of 30 degrees, 45 degrees and 60 degrees, and these are used an awful lot on the course. So it's a good idea to learn these, and there is a summary of the answers to these on the next slide. So let's have a look at the 30 and 60 degree angles first. And in order to do that, the first thing I'm going to do is I am going to draw an equilateral triangle of length 2. So here it comes, 2, 2 and 2. So I'm just going to put 2 here, 2 here and 2 here. And you hopefully will be happy that there is a 60 degree angle, and they're all 60 degree angles because it's an equilateral triangle. But what I'm going to do here is I'm going to drop a vertical line here, which is halfway through, and again, hopefully this isn't too much of a stretch to work out now that if I take that triangle out, that what I have here is, I know that's 90, I know that's 60, I know that's 30, I know that that there is still 2, and I have halved this base here, so that's going to be 1. So hopefully that isn't too much of a stretch. Now, just like before, that means that I can, using Pythagoras, I can work out the length of this side here, which means I'll have all of the lengths for this particular triangle. So I'll just quickly do that. That means I've got 1 squared plus x squared is equal to 2 squared. If we keep going, I've got x squared is equal to 2 squared, which is 4, minus the 1, x squared is equal to 3. And that means that x is equal to the square root of 3. So that there is the square root of 3. From here, I'm going to be working with the 60. I'll do the 60 degrees first. Okay, so I'm going to work with this one. So I'm just going to label the triangle. And if I label the triangle, I've got this is obviously my hypotenuse. This is my opposite, and this is my adjacent. Remember, I am using this angle here. And all I'm going to do is I'm just going to write the 3 trig ratios that I'm going to get. Okay, so I've got sine, I'll just write them down. I've got sine of 60, cos of 60, and the tan of 60 degrees. And we'll just go through them one by one. So equals, equals, equals. So sine of 60 is equal to the opposite over the hypotenuse, which is equal to, well, let's have a look here. The opposite is root 3. The hypotenuse is 2. So this is equal to root 3 over 2. Cos of 60 is equal to the adjacent over the hypotenuse, which is equal to, well, you can see here it's 1 over 2. So write that down. And then we have tan of 60, which is the opposite over the adjacent, which is equal to the opposite, which is root 3 over the adjacent, which is just 1. So it's root 3 over 1, which is the same as root 3. Okay, so I'll just put root 3 over 1 so you can see. Now what I'm going to do for the next one is I'm going to use the same triangle. Okay, so I'm going to use the same triangle here. I might actually just go up to here, just rewrite it. So it's the same triangle. But this time I'm going to use the 30 degree bit here. So this is the angle I'm going to use. Nothing else has changed in this triangle. It's the same. It's got root 3 here. We have 1. This is still 2. Okay, so We just got to relabel everything. The hypotenuse isn't going to change. That is still the longest side, which is 2. But hopefully you'll see now that the opposite now has changed to this one. That means the adjacent now is that one there. And I'm just going to very quickly run through them again. So what we have now, I'll just do it again in blue, that we've got sine of 30, cos of 30, and the tan of 30. And you can see here, sine of 30 is the opposite. So I'll just run through it. The opposite over the hypotenuse, so that's 1 over 2. The cosine of 30 is equal to the adjacent over the hypotenuse, which is root 3 over 2. And tan 30 is equal to the opposite, which is 1 over the adjacent, which is root 3. So this is equal to 1 over root 3. So I now have sine, cos and tan of 30 degrees and 60 degrees. I now need to be able to work it out for 45 degrees. And in order to do that, I'm going to draw a different triangle. So I'm just going to put a little box here just to show you it's a completely different triangle. And the triangle I'm going to use for this one is I'm going to use a right angle triangle of 1, 1. So you can see here, there's my right angle. And because this is an isosceles triangle, we should be happy that this is 45 degrees and this is 45 degrees as well. So that's where the 45 degrees comes from. Again, I don't have this length here, so I'm going to use Pythagoras in order to get that. It should be fairly straightforward. This one is 1 squared plus 1 squared is equal to x squared. And you see here, this sums to 2. So 2 is equal to x squared, and that means that x is equal to root 2. So I'm going to stick that onto my triangle as above. Now, it doesn't really matter which angle I decide to work with, they're both the same, but I'm going to go with this one just because we're used to labeling it in this slide with this angle. So very quickly, I'm going to label it. We know that this is the opposite, this is the adjacent, and this is the hypotenuse if we are using that angle there. Okay, again, very straightforward. We now have sine of 45, cos of 45, and tan of 45. Looking at sine 45, it's equal to the opposite over the hypotenuse. The opposite is 1 over the hypotenuse, which is root 2. So we have 1 over root 2. Cosine is the adjacent, which is 1 over the hypotenuse, which is root 2. So it's the same. And tan 45 is equal to the opposite, which is 1 over the adjacent, which is 1. So that's actually 1 over 1, which is equal to 1. So here's a summary of what we've just done, and you can see here as well, not only have we calculated the angles in degrees, but we've also put them to radians for you. Remember, 60 degrees is pi over 3, 45 degrees is pi over 4 rads, 30 degrees is pi over 6. And you can see here, this is just a summary of what we've done. These are in your tables books, but you should be using these so often in this course that you should be able to remember these. They shouldn't be too difficult for you. One other thing to note, that for example, if you put tan of 30 into your calculator, you are going to get the answer of root 3 over 3, which is not the same as what you're going to get in your tables book. It is exactly the same, but I know that you have used your calculator. The reason it's the same is as follows. If I take 1 over root 3 and I multiply it by root 3 over root 3, okay, that's the same as multiplying by 1, boys. Yeah, so multiplying by 1. I'm going to end up with root 3 on the top, because 1 times root 3 is root 3. And we know that root 3 by itself, the square roots will disappear, and we end up with root 3 over 3, which is what you get on your calculator. Your calculator does not like to have surds on the fraction. It will automatically get rid of it for you. However, it does mean that we know as teachers that you have just put something into your calculator, because if you actually knew these, you would know that tan of 30 is 1 over root 3, not root 3 over 3.